October 2025. Elon Musk drops a bombshell. Starship version 4 will pack over 1,000 cubic meters of pressurized volume. That's 10% more space than the entire International Space Station in a single rocket. But why does size suddenly matter for Mars missions? Standing 150 meters tall, with 42 Raptor engines pushing 10,000 tons of thrust, version 4 doubles its payload capacity to 200 tons. What could NASA do with twice the cargo heading to Mars? Welcome to Space Update 24 Hours. Let's dive right in. 6 months. That's how long it takes to reach Mars during a favorable launch window. Now think about the longest flight you've ever taken. Maybe 12 hours? 15? Now multiply that by 120. That's what astronauts face on a Mars mission. And here's the brutal reality. Cramped quarters don't just make people uncomfortable, they break them psychologically. SpaceX knows this. That's why Starship version 4's 1,000 cubic meters isn't just impressive, it's essential. Crew quarters, research labs, exercise equipment, medical facilities, storage for months of supplies. This is about keeping astronauts mentally sharp and physically healthy when there's no emergency return option. When Earth is just a blue dot in the rearview mirror, would you want to be trapped in a closet or have room to breathe? The numbers sound impossible until you see them broken down. Version 4 stands 150 meters tall, stack 3 statues of Liberty on top of each other, and you're still not quite there. The booster alone stretches 81 meters, packed with elongated propellant tanks. The upper stage, 61 meters of pure engineering ambition. But here's where it gets wild. Version 3 could barely manage 100 tons to orbit in reusable mode. Version 4, over 200 tons. That's not just an upgrade, that's a complete game changer. What does doubling your payload capacity mean for Mars? It means you can send robots, infrastructure, life support systems, spare parts, and emergency supplies before humans even leave Earth. You're building a Martian base camp from orbit. The fuel situation is equally staggering. 4,500 tons in the booster, 2,300 tons in the upper stage. That's enough liquid methane and oxygen to power a small city. But moving that much mass off the launch pad, that requires something special. SpaceX didn't just add a few more Raptors to version 4, they completely redesigned the engine layout. 42 Raptor engines in total. If you're a sci-fi fan, that number might ring a bell. It's the answer to the ultimate question of life, the universe, and everything, from Hitchhiker's Guide to the galaxy. Elon couldn't resist, but the joke has serious engineering behind it. The upper stage now carries 9 Raptor vacuum engines optimized for space efficiency, with specific impulses around 380 seconds. These babies are tuned for the vacuum of space, where there's no air resistance slowing them down. 3 sea-level Raptors sit at the center, gimbaled for steering and precision landings. The layout? 3 central engines surrounded by 6 vacuums in a hexagonal pattern. Why does that matter? Balance. That hexagonal configuration distributes thrust evenly across the structure, reducing stress points and making launches smoother. It's elegant engineering disguised as geometry. And the performance gains? The upper stage alone generates 2,700 tons of initial thrust, higher than any previous Starship iteration. But wait until you hear about the booster. 10,000 tons of liftoff thrust. Let that sink in. The Saturn V that took humans to the moon, about 3,400 tons. Starship version 4's booster will generate nearly 3 times that force. How is that even possible? Raptor 3 engines. Each one produces roughly 280 to 300 tons of thrust at sea level, using a full-flow staged combustion cycle for maximum efficiency. Multiply that across 33 engines on the Super Heavy booster, and you're looking at raw, earth-shaking power. But SpaceX isn't stopping there. Raptor 4 is already in development, targeting around 330 tons per engine. That's an 18% jump over Raptor 3. Do the math. 33 engines times 330 tons equals approximately 10,890 tons of thrust. That's enough force to make the ground tremble from miles away. Why does more thrust matter beyond raw spectacle? Speed. The faster you clear the boost phase, the less time you spend fighting gravity. Less gravity loss means more fuel left for the upper stage. More fuel means heavier payloads to orbit. Heavier payloads mean you can pre-position everything Mars colonists need before they arrive. It's a cascade of advantages, all starting with those 42 engines. Here's the thing about having 42 engines: redundancy. If one fails mid-flight, 41 others can compensate. This isn't theoretical, it's survival math. When you're carrying hundreds of tons of fuel and potentially hundreds of humans, single-point failures aren't acceptable. Starship also uses gas thrusters for fine-tuned steering. But if those systems fail, the main engines can still control the vehicle by adjusting individual thrust levels. That's called thrust vectoring, and it's your backup when Plan A stops working. With 42 engines distributed across the vehicle, you've got multiple redundant control systems. This is why version 4 is safer, despite being bigger and more complex. More engines mean more options when something inevitably breaks. And in space, something always breaks. There's one moment during launch that's particularly brutal: stage separation. Version 4 uses hot staging, lighting the upper stage engines while still attached to the booster. The problem? Those 6 vacuum engines produce exhaust temperatures hot enough to melt steel. Fire them all at once, and you risk damaging the booster's heat shields and grid fins. SpaceX's solution? Staggered ignition. Light the engines one by one in a carefully choreographed sequence, managing the thermal load. The result is smoother, safer separation without roasting the hardware you need to reuse. It's the kind of problem you don't think about until you realize the booster needs to survive re-entry and land itself on a tower. So when does all this hardware actually reach Mars? SpaceX is targeting 2026 for the first uncrewed missions, timed with Earth-Mars orbital alignment. 5 missions designed to test entry, descent, and landing. No fancy landing legs on these early attempts, just minimally equipped landers, proving the concept works. If those missions succeed, the first Starship arrives on Mars in 2027, carrying an undisclosed number of Tesla's Optimus robots. Not humans, robots. Why? Because someone needs to build infrastructure before people show up. These bipedal machines will survey resources, locate water ice deposits, and start construction on basic facilities. By 2028, the plan scales dramatically, 20 Starships launching during the next transfer window. Most ferry additional Optimus units. At least one carries human passengers. Then the numbers get truly ambitious: 100 Starships in 2031, 500 in 2033, eventually reaching 1,000 to 2,000 ships per Mars launch window. Each crewed Starship would carry 100 to 200 people. Robert Moses, a retired NASA aerospace engineer, reviewed SpaceX's plan. His assessment? I like it a lot. He notes that SpaceX is hitting all the key technical elements you'd expect in a serious Mars architecture. Compared to NASA's reference missions, SpaceX's plan involves hundreds more spacecraft and crew, but the underlying strategy is sound. But there's a massive technical hurdle no one's solved yet: orbital refueling. Robert Zubrin, founder of the Mars Society, breaks down the math. A Starship flying a 6-month trajectory to Mars needs roughly 600 tons of methane oxygen propellant after reaching low Earth orbit. SpaceX's current plan requires 6 Starship tankers to refuel the mission vehicle, all within a single launch window. Miss that window and you're waiting another 26 months for the orbital alignment. Can you coordinate 6 successful tanker launches, orbital rendezvous, and propellant transfers in a matter of weeks? That's the question keeping engineers up at night. SpaceX is exploring an interim solution: Starboat. Think of it as a smaller, lighter cousin of Starship, about 5 times lighter. A single Starship could launch a Starboat fully fueled, carrying 5 to 25 tons of cargo directly to Mars. No orbital refueling ballet required. The advantage? Unprecedented surface mobility. With 100 tons of fuel, a Starboat could transport a crew 2,200 kilometers across Mars, covering an area nearly twice the size of the continental United States. It could also make a direct return trip to Earth using just 50 to 120 tons of fuel, depending on whether it lands on Mars or rendezvous with a mothership in low orbit. Even Elon Musk admits the 2026 timeline is optimistic. He suggested a more realistic schedule. Maybe an Optimus robot flight in late 2026, first uncrewed mission in 2029, crewed mission in 2031. The ultimate goal? A self-sustaining city on Mars by 2045 to 2055. Moses believes that even delaying the first missions to 2028 provides enough runway for a robust buildup before the critical 2033 window. The question isn't whether SpaceX can build the hardware. Version 4 proves they can. The question is whether they can orchestrate the most complex logistics operation in human history. So what does Starship version 4 really represent? It's not just about bigger rockets or more powerful engines. It's about answering a question humanity has been asking since we first looked up at the night sky. Can we actually become a multi-planetary species? The numbers tell the story. Over 1,000 cubic meters of living space, 10,000 tons of thrust, 200 tons of payload capacity, 42 Raptor engines providing redundancy when failure isn't an option. These aren't just specifications. They're the blueprint for survival beyond Earth. Will SpaceX hit their 2026 target? Probably not. Musk himself admits the timeline is aggressive. But here's what matters. The engineering is real. The hardware is being built. Version 4 isn't science fiction. It's actively being designed right now at Starbase, Texas. Within the next decade, we'll likely see Optimus robots walking on Martian soil. Within 2 decades, humans might be living in habitats built by Starship. And within 3 decades, maybe that self-sustaining city Musk keeps talking about. The question isn't if we're going to Mars anymore, it's how soon. What's your take? Do you think SpaceX can pull off their 2029 timeline? Drop your thoughts in the comments below. If this breakdown got you as fired up as we are, smash that like button and share this with anyone who needs to see what's coming. And subscribe to Space Update 24 Hours. We're tracking every development as humanity takes its next giant leap. The future is being built right now. Don't miss it.